Let us know about the quantum numbers. There are four main types of quantum numbers. They are principal quantum number, the angular momentum quantum number, the magnetic orbital quantum number, spin quantum number. Click each tab to learn more. Principal quantum number. It gives the size and energy of orbitals. The allowed values of n are non-zero positive numbers 1, 2, 3 up to n. As the value of n increases, the region and the energy of the orbital also increases. The electrons of higher energy levels or shells or orbitals are also farther from the nucleus. Sometimes letters K, L, M, N, etc. are also used to represent the higher energy levels. If the principal quantum number is n, the number of electrons in that shell is 2n squared. The angular momentum quantum number. It gives the shape of the orbitals occupied by an electron and its orbital angular momentum. The allowed values of this number are 0 to n-1 for each value of n. Each L value represents one subshell. With every value of L, a unique shape of an orbital around the nucleus is associated and with a specific name. For L is equal to 0, 1, 2, 3, the names of the orbitals are S, P, D and F respectively. When n is equal to 1, there is only one subshell with L is equal to 0. This is designated as 1s orbital. For instance, when n is equal to 2, the values of L are 0 and 1. So the two subshells within the shell n is equal to 2 or 2s and 2p respectively. Magnetic orbital quantum number. Electrons from same principal quantum number n and orbital quantum number L differ differently when the atom comes under the influence of magnetic field. For example, Zeeman effect. This event is taken into account with the help of magnetic orbital quantum number ML. This quantum number also gives the orientation or direction of an orbital in the atomic space. The value of ML is based on the direction of the orbital quantum number L with the direction of the external magnetic field B. The allowed values of ML are minus L to plus L, including 0. It means for a given value of L, the allowed values of ML are 2L plus 1. The number of electrons held in the 2L plus 1 equal energy subshells are 2 into 2L plus 1. When L is equal to 0, 2L plus 1 is equal to 1 and there is only one value of ML. Thus we have only one orientation of orbital, that is 1s, which refers s orbital of shell 1. When L is equal to 1, 2L plus 1 is equal to 3. That means ML has three values, namely minus 1, 0 and 1. Thus there are three orientations of p orbitals along x, y, z axis. These are labeled as px, py and pz. The magnetic orbital quantum number ML indicates the number of orbitals in a subshell with a particular L value. Orbitals in the subshell belonging to the same shell possesses same energy with different orientations. Hence px, py and pz have same energy, but they differ in their orientations. The shapes of s, p and d orbital are shown on the screen. S orbital is spherical in shape, p orbital is dumbbell shaped and d orbital are double dumbbell shaped. Each subshell holds a maximum of twice as many electrons as the number of orbitals in the subshell. 2 into 2l plus 1. The maximum number of electrons that can occupy various subshells is shown on the screen. Spin quantum number. The three quantum numbers n, l, and ml, which describe the size, energy, shape, and orientation respectively of an atomic orbital in space. As you have observed in the case of street lights, sodium vapor lamp, yellow light is emitted. This yellow light is comprised of a very closely spaced when analyzed using high-resolution spectroscope. Alkali and alkaline earth metals show such type of lines. To account for such a behavior of electron, an additional quantum number is introduced. This is spin quantum number. This quantum represents spin of the electrons about their own axis. It is denoted by ms. There are two possible ways in which an electron can rotate along its own axis apart from revolving around the nucleus. They are clockwise and anti-clockwise rotations. The spin motion of an electron along its axis is taken into account by the spin quantum number. The possible values of ms are +1/2 and -1/2 respectively. When the spin values of both the electrons is positive, it means that their spin is parallel. Otherwise, their spin is anti-parallel. The importance of spin quantum numbers is realized when multi-electron atomic systems are studied. Spin reversal causes emission of radiation, which appears as a unique spectral line. After learning about the location of an electron in an orbital, let us now learn about the ways in more than one electron occupy different orbitals in an atom.